Good afternoon. Myself Stanam Singh, lecturer electrical engineering, Government Polytechnic College, Mohali, Khuni Majra. Today we are going to discuss the construction feature of DC machine. So these are the content which we will discuss in our today's lecture. First is overview of direct current machines, construction, principle of operations, type of DC generator and types of DC motors. The learning object of this lecture is upon the completion of this chapter, the student should be able to state the principle by which the machines convert mechanical energy into electrical energy, state the different part of DC machine, discuss the different operating difference between different types of generator and motor, understand the principle of DC generator and DC motor. So, student would today we will discuss the DC machines, construction feature of DC machine. Before explaining the construction feature of DC machine, first we should be familiar with the DC machine. What is DC machine? So, this is the overview of direct current machines. So, first the question arises, what is machine? A machine is an electromechanical energy conversion device which convert the form of energy, that is from mechanical to electrical or from electrical to mechanical. So, machine is a electromechanical energy conversion device, means it convert electrical to mechanical or mechanical to electrical. So, electromechanical energy conversion device, it convert the energy from one form to another form. Depending upon the working of the machines, the electromechanical energy conversion device may be named as generator or motors. So, this machine can be named as motor or generator. So, these are the basic parts of direct DC machines. It basically consists of two parts, first is stator and second is rotor. So, in figure you can see the stator, rotor, and this is the shaft on which this rotor is mounted, and this is the end houses containing bearing. This is for just housing the this all the stator and rotor at the on the end point, and this end housing contain the bearing here. The purpose of bearing is to reduce the friction at the end point. So, with the help of this dotted line you can see that where the nut and bolt and where the bearing. DC generator. So, depending upon the function of machine, it can be named as motor or generator. So, first is generator. Generator is a machine that convert mechanical energy into electrical energy by using the principle of magnetic inductions. So, if the machine convert mechanical energy into electrical energy, then it is called a generator. The generator work on the principle of magnetic induction, that is when this conductor is placed in the magnetic field, whenever this conductor cut the magnetic field and EMF will induced in this conductor. So, this is the DC generator. Next is principle of DC generator. Basically, the machine consists of two main parts, that is stator and rotor. Here this magnet north and south are stationary part, and this conductor or coil is a rotating part of the DC generator. So, first we will apply mechanical energy, as it is a generator. When we apply mechanical energy, that is Tm torque, mechanical torque, in an anticlockwise direction, then this conductor will rotate in anticlockwise direction with the help of this Tm, mechanical torque Tm. So, mechanical, the direction of Tm is in anticlockwise direction, as well as the direction of this omega, that is angular velocity of this conductor will also in the anticlockwise directions. So, first action is this coil or conductor will cut the magnetic flux, and whenever as you know, whenever the magnetic flux is cut by the conductor, an EMF will induced in this conductor. So, whenever this conductor cut the magnetic flux, an EMF will induce in this conductor and current start flowing in the load. So, first action is an EMF will induced whenever this conductor cut the magnetic flux. So, student, first action is EMF is will induced in this conductor. Now, the second action start. Now, the second action is whenever current carrying conductor, now this conductor becomes current carrying conductor. Whenever the current carrying conductor placed in a magnetic field, a force will exerted on the conductor, or the direction of this force will be opposite to that of Tm. So, T is representing the electrical torque, that is torque produced by this electric current. So, the direction of T is in opposition to the Tm, and third next is Tf. This is the frictional torque. It will always act in it will always act opposite to the input torque Tm. So, Te and Tf will in phase opposition with the Tm. So, Tm is, that is mechanical torque will equals to Te plus Tf. So, mechanical torque has to overcome the electrical torque and frictional torque. Now, if we multiply this relation with the omega on both the side, then omega Tm equals to omega Te plus omega Tf. This omega Tm is mechanical input power, omega T is mechanical power available for conversion into electrical power. So, this is the power, that is omega T, mechanical power, which is available for conversion into electrical power, and this is the omega Tf, that is mechanical power lost, that is mechanical power lost due to friction. So, this is the power which will lost to overcome the friction. So, only this omega T will be available for conversion into electrical power. Next is DC motor. A DC motor is a machine that converts electrical energy into mechanical energy by supplying DC power. So, this is the same machine now will act as a motor. When we apply the electrical energy to this machine, now it will act as a DC motor. Working principle of motor. Same way, now this machine will act as a motor. The difference between the generator diagram and motor diagram is we have replaced this load R with the battery. In the case of generator, here load resistor R was connected. Now, we have replaced the load resistor R with the battery with a voltage V. Now, the first action is the current will flow from battery to rotor. Now, this is the case current carrying conductor placed in a magnetic field. Now, when a current carrying conductor is placed in a magnetic field and force will exerted, and this is the first action. So, when the force will exert, the Te, that is electrical torque, will flow in the anticlockwise direction. You can see the direction of T is in the anticlockwise direction. With the help of with the application of this Te, this rotor, which was previously stationary, now start rotating in an anticlockwise direction. So, first action is current carrying conductor placed in a magnetic field, a force, a torque Te will exert on this conductor. Now, the second action will start. The second action is whenever current carrying conductor is rotated in a magnetic field, and EMF will induced in this conductor, and a torque Tm will induce. The direction of torque Tm and Tf is opposite to the torque Te. So, you can see in this animation that the main field, that is field of this permanent magnet north and south, is from north to south. Now, this is the second field, this is the main field, and this is the rotor field. Here this is a battery. When we connected battery to the coil or conductor, a current will flow in this conductor, which will produce an rotor field. This field, this green line, will tries to come in line with this main field. When this rotor field tries to come in the main field, the force will exert on this conductor and it will start rotating in the direction of alignment of these two wheels. That is the torque will induce with the help of the interaction of these two fields, that is main field and rotor field. Now, more clearly, this is the diagram of electric motor. This is magnet, which is called field magnet, and this center line, that is black line, is a this black circle is a axle. This is the commutator, this green line, and this red line is a brushes, and these are the winding, armature winding. Now, this is the diagram of electric motor. So, battery will connected to the armature windings. When current flow through this armature, and the rotor field will induced, and with the help of with the interaction of the main field, that is field of field magnet, and rotor field, a torque will exert on this rotor. Here you can see a rotor is rotating. This red line, which was brushes, they are used, they are not rotating, they are used to carry the current to the field winding, sorry, to the rotor winding. So, from the battery to the armature winding, these brushes will help to supply the current to the rotor winding. Next is construction. The main part of DC machines are field magnet frame or yoke, pole core and pole shoes, pole coils or field coil, armature core, armature winding, commutator, brushes, brush holder, bearing and shaft. So, these are the main part of the DC machines: yoke, pole core, pole shoes, this is the armature winding, this is rotor, commutator and brush holder, and this black is the brushes. This is a shaft. So, first part is field magnet frame or yoke. The yoke or outer frame is a covering provided to DC generator, and it serves the following purposes. First is it provide a mechanical support for the poles. Second, it act as a protective cover against mechanical damage. Third is it provide a passage for magnetic flux produced by the pole. So, this outer covering is called yoke. It serves three purposes. First is it provide support to these pole core and pole shoes. Second, it provide protection against mechanical hemorrhage to the internal part, that is field winding, armature winding, pole core and pole shoes. So, it provides the mechanical protective covering against mechanical damage. And third one is it provides the easy path for the flux. Pole core and pole shoes. Pole core itself may be made of solid piece of cast iron or cast steel, but pole shoes is laminated and is screwed to the pole face by means of countersunk screw. The pole cores may be made of thin lamination of steel riveted together. This type of pole is held in position with the frame by means of bolts. The pole shoe serves the two purposes as under. First, it supports the pole coils. Second, being a large cross sectional, it spread the flux and also reduce the reluctance of magnetic path. So, this is the pole core and pole shoes. You can clearly see that the cross section of pole shoes, this is the pole shoes, is more than the cross section of pole core. This is the pole core. So, in this diagram there are 4 set of pole cores and pole shoes, first, second, third and fourth. So, pole core, around the pole core we accommodates the windings, and the purpose of pole shoes is to support the, this is this circle with dot, it is representing the rotor windings. So, sorry, field windings, these are representing the field windings. So, pole core houses the field winding around it, and pole shoes support these windings. And second purposes of these pole shoes is it spread the large it spread the flux and reduce the reluctance. Having a larger cross section, it reduces the reluctance. Next is armature. The armature core is cylindrical in shape. It is rotating part of the machines. Its body is made up of soft iron stamping or lamination to reduce the eddy current losses. The laminations are keyed to the shaft. These are insulated from each other by varnishes. So, this is the armature. You can see at the outer periphery the slots are cut. In these slots we will accommodate the rotor conductor or rotor windings. Student, as you seen, these rotor conductor are skewed, that is they are not straight, but lined at some angles. This is called skewing. This skewing is done to reduce the noise created by this machine. Next is armature windings. Armature coils are usually former wound. The conductor are placed in the armature slots which are lined with tough insulating material. The slot insulation is folded over the armature conductor, placed in the slots, and is secured firmly by bamboos or fiber wedges. The armature windings are usually of conductor covered with single cotton cover, double cotton cover, or enameled wire. On the basis of connection, these are of two types. First is lap winding, second is wave winding. So, first is lap winding. In lap winding, number of front path is 2 times number of poles. The lap winding are used in machine designed for the low voltage and high current. Armature are constructed with large wire. Because of high current, the winding of lap wind armature are connected in parallel. This permits the current capacity of the each winding to be added and provide a higher operating current. So, all the windings in lap wound armature are connected in parallel, and number of current path is 2 times number of poles. Wave wound armature. In wave wound armature, the windings are connected in series and number of current path is 2. When the winding are connected in series, the voltage of each winding adds but the current capacity remain the same. Number of current path in wave wound armature is 2. So, students always remember the number of current path in wave wound is 2 and number of current path in lap wound is 2 times number of poles. C is equal to 2p in lap wound and in wave wound C is equal to 2. So, you can clearly see the lap winding and wave winding. In this, number of current path is 2 times number of poles. In this, in the wave winding, number of current path is only 2. Field winding. Most DC machines are wound electromagnet to provide the magnetic field. When current passed through these coils, they electromagnetize the poles, which produce the necessary flux, which is cut by the armature conductor when in motions. Two types of field windings are used: series field, shunt field. Series field winding. Series field windings are so named because they are connected in series with the armature, are made with the relatively few winding turns of very large wire and have a very low resistance, usually found in large horsepower machines wound with square or rectangular wire. The use of square wire permits the winding to be laid closer together, which increase the number of turns that can be wound in a particular space. So, series windings are connected in series with the armature. Shunt field winding. Shunt field winding is constructed with relative many turns of small wires, thus it has much higher resistance than the series field. It is intended to be connected in parallel with or shunt the armature. So, shunt field winding is connected in parallel with the armatures. So, windings, there are two windings are used in DC machines. First is armature winding and second is field winding. Armature winding is wound on the rotor and field winding is wound on the stator. Field winding are used to produce the magnetic flux. Armature windings are of two types. First is wave winding, number of current path is 2, and lap winding, number of current path is 2 times number of poles. And field windings are of two types. First is self excited, second is separately excited. Self excited are further of three types: series field winding, shunt field winding, and compound field winding. Commutator. Commutator is a cylindrical in structure and is built up of wedge shaped hard run copper segment. The segments are insulated from each other by a thin sheet of high quality mica. To prevent them from flying out under the action of centrifugal force, the segments are provided with V grooves, which are insulated by a conical micanite ring. The function of the commutator is to facilitate the collection of current from the armature and to rectify the AC induced in the armature into DC. So, main purpose of commutator is to rectify the AC into DC. The function of brushes is to collect the current from commutator and supply it to the external load circuit. The function of brushes is to collect the current from the commutator. So, brushes just collect the current from the commutator. They are usually made of carbons and are rectangular in shapes. These brushes are housed in brush holder. These are held in position under spring tension. The pressure of spring can be adjusted by altering the position of lever in the notch. Copper brushes are only used for machine delivering large current at low voltage. Next part is bearing. These are sported in end cover because of reliability. Ball bearing are usually employed. They are heavy duty. Roller bearing are employed. These are used to reduce the friction and have less wear and tear. So, bearing are used to reduce the friction. Shaft. The material of shaft is mild steel. It is used to transfer mechanical power from or to the machines. The rotating part, for example armature, commutator, are mounted to the shaft. Now, principal operation of generator. The main the basic principle of generator is electromagnetic induction, that is whenever conductor is moved within a magnetic field or whenever conductor cut the magnetic field in such a way that conductor cut across the magnetic lines of flux, voltage is generated in the conductor. So, whenever conductor cuts the magnetic flux, an EMF will induced in the conductor. The amount of voltage generated depends on strength of magnetic field, angle at which conductor cuts the magnetic field, speed at which conductor is moved, and the length of conductor within the magnetic field. The polarity of voltage depends on direction of magnetic lines of flux and direction of movement of conductor. To determine the direction of current in a given station, left hand rule for generator is used. So, to find the direction of current in a any given station, left hand rule are used. In left hand rule, we will stretch the left hand and the thumb will indicates the motion of conductor. First finger will indicates the flux, then second finger will indicates the, that is middle finger will indicates the direction of current. So, with the help of this left hand rule we can know the direction of current. So, thumb in the direction of conductor is being moved, forefinger in the direction of magnetic flux, middle finger will point in the direction of current flow in an external circuit to which the voltage is applied. Elementary generator. So, generator consists of two parts, stator and rotor. Here we use the permanent magnet north and south. Flux will flow from north to south. In this magnetic field, we will place a coil having 1 turns and collect the current using slip ring and brushes. The simplest elementary generator that can be built is an AC generator. Basic generating principles are most easily explained through the use of elementary AC generator. For this reason, the AC generator will be discussed first, the DC generator will be discussed later. So, the generator, it will generate the AC. So, before explaining the DC generator, first we will discuss the AC generator, then we will shift to the DC generator. The main difference between AC generator and DC generator is that if we in AC generator, in any generator the output is AC. If we want to generate DC, then we will connect the commutator which will rectify the AC into DC. So, and this is the simplified diagram of this diagram. An end view of the shaft and wire loop is shown. At this particular instant, the loop of wire, the black and white conductor, is parallel to the magnetic lines of flux and no cutting action is taking place since the lines of flux are being cut by the loop. No EMF is induced in the conductor and the meter at this position indicates 0. So, now we will discuss the different position of conductor and correspondingly flux cutting and EMF induced in the conductor. So, first position is this position, that is 0 degree angle. So, this is the white conductor and this is the black conductor. Actually, this is the white conductor is representing the end coil of this red line, and black conductor is representing the coil side of this conductor, this green side. So, this red line is representing by white and this green coil side is representing by the black. So, first position is when the angle is 0.